Good morning, everyone. Welcome to the Made Smarter Innovation Sustainability Accelerator. Thank you all for joining us today. We're going to wait a few minutes for everyone to attend, and then we'll get started. Before we kick off, just a few bits of information to give up front. So just for everyone's awareness, these sessions will be recorded and available later on the Digital Catapult YouTube channel. Also, please feel free to use the chat box at the bottom of your screen at any questions you may have as we are going through. We will address them in a dedicated Q&A sessions at the end. Before we jump in, just a very quick introduction to myself. My name is Iani Vodimirova, Innovation Delivery Manager here at Digital Catapult. And I have been working alongside our industry challenge owners, BAE Systems, Craig Concrete, and HS2 to help define and scope the challenges and set up the program Open Code together with my colleague Gavin Burns, who is the innovation partner and program lead, together with also a number of colleagues working on this program. To get started, the flow of today is going to be a very quick introduction to the Digital Catapult, an overview of the Made Smarter Innovation Sustainability Accelerator, how to apply to the program, what are the benefits, and what are the selection criteria is for joining and being selected for the program. We'll then move on to hearing from our industry challenge owners around their real-world challenges in more detail that we will look to address over the course of the program. And as I mentioned at the end, we'll have some time for Q&A at the end of the sessions to cover any questions you might have from today's content. Digital Catapult is the UK foremost authority on advanced digital technologies, and our mission is to accelerate the adoption of advanced technologies and create new opportunities through collaboration and innovation. And we do this by delivering specialized acceleration and innovation programs aligned to industry challenges and teams. We also build test-bed facilities, we run pilots and proof of concepts, and we test new business models. We also facilitate research and development projects, we inform the policy recommendations and lead research on emerging tech trends, and we work with partners across governments and public sector, startups, scale-ups, corporates, industry investors, academia, and the wider Catapult network. We operate at 3 system applications areas, which includes virtual environments to enable the UK cyber physical future through metaverse and digital twins. Secondly, supply chain to drive resilience, trust, and net zero across our supply chains. And we accelerate the diversification, openness, and interoperability and security of digital infrastructure. We do this by exceptional expertise, experience, and authority across 5 key advanced digital technologies. These are the future networks, which encompass things like 5G and Internet of Things, immersive technologies, things of augmented reality, virtual or mixed reality, and haptics, artificial intelligence and machine learning, distributed ledger system, and distributed technologies, so think of blockchain and ledger-enabled technologies, and last but not least, quantum technologies like quantum computing and other technologies. Now I would like to introduce you to Made Smarter Innovation Sustainability Accelerator, which is part of the wider Made Smarter national movement funded by Made Smarter Innovation Challenge and Innovate UK. The program is led and delivered by Digital Catapult, and is designed to accelerate sustainable manufacturing and leverage cutting-edge technologies to drive environmental impact. The program provides UK manufacturers the opportunity to fast-forward their adoption of digital solutions that deliver resource efficiency and energy efficiency into the industry. Built on the success of previous Made Smarter Technology Accelerator, this is a great opportunity for tech innovators to work with leading UK manufacturers and develop digital solutions tackling real industry-specific sustainability challenges with the time frame of the program. And the mission of this accelerator program is to help tech innovators and enterprises to develop and validate digital solutions targeted at industry-specific challenges that deliver resource efficiency and energy efficiency to the industry owners. On Wednesday, 21st of April, we launched the open call for this 8-month program for UK-based tech accelerator, startups and SMEs. The program comes with many benefits, including grant funding, industry expertise, tech and product development support, and pitch training. Lastly, there will be an opportunity to present your progress to industry representatives, potential investors and commercial and customers at our final showcase along our industry challenge owners. This is a brief overview of the program timeline. As I mentioned, Open Call is already live and it will be closed on 1st of April. Companies that have reviewed will be notified, it will be notified of their result by 3rd of May. And those successful begin contracting. The program launch date is on 19th of June, and this is in person at Digital Catapult office. The next key date is the midpoint review, which takes place online the week commencing 14th of October, and the final showcase will be in person again in February 2025. The program operates in 2 phases. Phase 1 is the prototype development, which is from June to October. During this phase, 8 selected companies will receive £75,000 funding and a range of support to develop technology solutions for their chosen industry challenge. The companies will have the opportunity to pitch, demonstrate product development progress, and share lessons learned at midpoint review, where 4 companies from the original teams will be down selected for phase 2. Each team will receive additional £100,000 to further develop their prototypes within a pilot environment. The cohort will gain access to investment support, pitching workshops, and support from the key manufacturing and industry leaders to become investment ready. Now I'm going to walk you through the application and selection process, and then I will introduce our challenge owners who will be presenting the challenge areas for this program. So the application process is very simple. If you follow one of the links either on our website or social media, you'll be taken to a platform called Skipso. First, you need to create an account. If you haven't already, then you can fill out the application form, which needs to be completed by 1st of April. Once submitted, you'll not be able to make any edits to your applications. Please also check if you receive a confirmation email when you have submitted your application. If you do not receive one, please get in touch with us through the Made Smarter Sustainability Accelerator email address, which we will be sharing at the end. In order to be able to apply for this program, you must meet these minimum requirements. So applicants must be eligible to receive £190,000 in state aid assistance for the whole duration of the program from June 2024 until February 2025. Applicants must be also a UK-based registered company and must develop solutions enabled by advanced digital technologies at the TRL 4-5 with the potential for progression to TRL 6-7 at the end of the program. The selection criteria is based on these 4 selection criteria. Challenge and solution. The applicants should demonstrate that their company is addressing a clear problem as they're applying advanced technologies to tackle the challenges in the selected focus area. The team experience, the team should demonstrate that they're also equipped with appropriate technology and business skills and have a good track record to develop and deliver the proposed solution within the time frame of the program. Technical feasibility, as I already mentioned, the proposed idea should be at TRL level 4-5 with potential to progress to TRL 6-7 at the end of the program. And last but not least, growth potential. The idea should demonstrate some scalability and has the potential to succeed beyond the program. In terms of the selection process, consists of 3 main phases. Firstly, long list and share phases, where we're going to review your written application by Digital Catapult judges, which will be result in shortlisted candidates. Then the second phase is it will be shortlisting phase, where the internal review will take place with the program judges. Will shortlist 4 companies for each challenge who they would like to invite for an interview. And the last phase is the interview phase, where there will be an interview with Digital Catapult judges and the relevant industry challenge owners, in which you'll be need to prepare a short presentation on your proposed idea, and then there will be an opportunity for Q&A at the end. The interviews will take place between 23rd of April and 26th of April. And if applicants are not able to attend the interview in person, there will be an option to attend virtually. Following the interviews, the judging panel will deliberate and select the final cohort of 8 companies, so 2 companies for each challenge to join the program. Now we'll have the opportunity to hear from the challenge owner about the challenges from the industry challenge owners directly. Firstly, I would like to welcome BAE Systems, who will be introducing the Factory of the Future Environmental Control System Challenge. Welcome to James. Okay.
Good morning, everybody. Can you hear me?
Yes, we can hear you.
Fantastic. So first of all, please accept my apologies. You can't see me. For some reason, the camera kills the feed. I promise you are not missing much. So, good morning. I'm James Ledbetter, and me and my colleague Cenk are going to be taking through this project today. We're first of all going to just give you a quick breeze through an introduction as to BAE as a company, honing in on the area of the business we work in, and explaining then the art of the project and what we want to find with your help in this program. I'd first of all like to mention that we have done our work with Digital Catapult in the past, and the last time we did this project, the successful company did a really good job, and now we're at the point of actually launching a full product with them in our Future Factory environment because of the work that was spearheaded by this very initiative. So we're very excited to see what can be done in this bid process. Next slide, please. Okay. So BAE Systems is a big company. I won't hammer on it too much, but the key thing to make people clear on is we do lots of different things in lots of different sectors, and it isn't just about technology-led defence. We develop a lot of technology export opportunities. We have moving into a lot of different areas. We have a very big foothold in areas like digital, in AI, and wider. So this is a very relevant space for us to continue to push in. Next, please. So Falcon Works. Now, me and Cenk, we work in an area called Falcon Works. So it's part of our air sector division. Again, this is where we focus on all things flying, but at the same time, I mentioned it's all about technology development that supports that. And what me and Cenk work on in Falcon Works is the manufacturing technology development area. It's the development of new technologies that spearhead better manufacturing processes, and it all links into our net zero strategy, where while we're developing smarter, better ways of making things, feeding back information to customers, to suppliers and wider, it's also about doing that in the most efficient and sustainable way we can. After all, we are 1% of UK GDP as a company, and we rub shoulders with thousands upon thousands of suppliers, large and small, to do all this, and we have done for decades. Therefore, it is in our, not only our interest, but it's our responsibility to do the right thing and to drive this sort of thing forward. Next, please. So hopefully these will come through smoothly. The next things we wanted to do was basically show you where this works. So what you're looking at now is a short video of some example technologies in our Factory of the Future environment. These videos were taken over a year ago. Lots of things have grown and changed since then, but we have a lot of cutting edge, bleeding edge manufacturing, assembly, cooperative, collaborative, digitally connected, high intelligence manufacturing systems in development here. And the whole point of this project is to link the environmental piece with this, whilst continually considering things like consumption, efficient usage of resources, and the environment that all these pieces of equipment are sited in, i.e. the Factory of the Future itself. You'll see in here we have various robotic assembly systems, but we also have the ability to work collaboratively with people. So it's not just a make this environment good for the better of the processes themselves, but the people that work on them too. Next slide, please. So the Factory of the Future is, and this is just an isometric view of what the place is. I won't go through all the headings, and you can't probably see them in your feed, but essentially this is where the project is going to be sited that Cenk is about to take you through. We plan to implement environmental monitoring to develop an understanding through algorithm development, through the use of AI, in order to understand what the best way forward for creating a suitable environment for turning this into a full-fledged factory is. The video you saw was on the left-hand side where the robotic assembly systems are, and on the far right we have further sub-assembly systems, and we have a large office environment and a HMI hub where all of the information is displayed as well. That's in the center. Okay, I'd like to hand over to my colleague Cenk now, who's going to explain the nature of the challenge that we have set.
Thank you, James. Good morning, all. I am Cenk Kapatlı. I'm working for James. In this project, I will take you through now what we are aiming to develop as part of environmental control system for our factory of the future. So can we go to next slide, please? Yes, so this is a slide so that I can explain what is our strategy on environmental control system for the factory of the future. And basically, on top of the slide, you can see that we have manufacturing environment, which James just explained, and we have our office environment within the same building. And our aim is to use our early prototype of IoT environmental sensors, and we are going to place them onto our manufacturing environment next to our robots and next to our workstations. And as well as the manufacturing environment, we are aiming to put a number of environmental sensors into our office environment to meeting rooms so that we can understand what is the temperature, what is the humidity, what is the light levels within our manufacturing and office environment. And as well as those environments, we are going to deploy a weather station, which we are going to mount that on the top of our factory. And we are going to combine this data with weather forecast. And all these data are going to be stored in a database that we are going to set up in our edge PC, which is going to run fully locally in our factory of the future. And in addition to those data streams, we are going to get facility data in regarding energy consumption data, natural gas usage, and we are going to understand how our heating and ventilation system is working within the factory of the future. And as well as those data, we are going to work towards to get data around process requirements, operational schedule, room bookings, and occupancy, which all those data can be simulated. And at the end of the day, we are going to collate all the data into the database. And what we are aiming to do here is going to develop an artificial intelligence technology, which is going to run locally by using our data. And as a result, we are going to look for environmental control, lighting control, or utilization planning, operational efficiency, dashboarding, and mapping. So all point of this project for us is to understand how environmental factors and effects change the operational of our operations within Factory of the Future. So just to give you a context, our Factory of the Future is based in Wharton, and it is inside one of the oldest buildings within the facilities. And the heating, insulation, ventilation systems are all for 20 years old. And in this old building, we are producing low volume, high tolerance, and highly flexible advanced manufacturing processes. And the workshop that you have just seen in the video, we have a robot floor which is highly flexible, which will enable us to generate and produce a number of different products in different times, changing time scales. And we don't want to just have a controlled environment for our manufacturing environment, but we are more like after to understand how the environmental factors are affecting our production, how these are affecting our tolerances, and we want to have an artificial intelligence technology so that we can manipulate the data that we have and we can change our processes, or we can have a better planning. So as part of this project, we are not setting a direct direction that we ask for the development of environmental control or another system. But what we are looking for is to have the capability to take data into consideration and different changing factors, and as a result, a system so that it can advise us how we can change the controls. Can we go to the next slide, please? So this is our environmental control strategy timeline. And as you can see, at the top of the line, you can see Digital Catapult Made Smart Innovation Sustainability Accelerator running from Q1 2024 and February 2024. And under this project, we are going to have a number of different activities which will involve environmental data collection so that we have the supporting data in order to develop this technology and help yourselves so that you can be onboarded to the project. For us to get this environmental data collection, we are working with a number of different suppliers as part of our strategy. And we are looking forward, as I said, to get process meterings, environmental sensors integration, network integration, and facilities data capture so that we can generate the relevant and necessary data for this project, which all the data is going to be given to yourselves at the beginning of phase 1, which is the prototype development. And while doing this environmental data collection, we are also going to work together with our graduates, which we call MGP, and we are going to involve them from day 1, which they will be helping us to get the user stories within Factory of the Future, understand what is our problems, what are the main hitting points for us, what are the quick wins so that we can do and implement those improvements to have a better understanding, and they will be helping us to set up the right environment. And as part of this project, we will be looking for low-hanging fruits within the Factory of the Future, and we will be looking to generate and develop our wider sustainability strategy within Factory of the Future. Can we go to the next slide, please? So as key expectations, as I mentioned earlier, we are interested in understanding and articulating the manufacturing environment and effect of changing environmental factors on the low volume, high tolerance, and highly flexible advanced manufacturing processes. We want to utilize the environmental monitoring data along with artificial intelligence to create resource and energy efficiency insights to improve our carbon emissions while not affecting the production throughput. But while developing that technology, because of the security restrictions and cybersecurity concerns, we are looking to develop artificial intelligence or LLMs on local basis only, and we want to offload our data onto that system. But at the end of the day, we don't want to store any data on cloud environments, or we don't want to have our system to be on cloud servers. So we are going to require our technology to run on local machines with further capability to be hosted over cloud systems or live data integration to the system. We want to understand and to work towards tighter and more quantified thresholds to lower the emissions while ensuring there are no concerns around affecting critical manufacturing processes, because as mentioned earlier, we are looking forward to develop different range of products on highly flexible manufacturing processes, and each manufacturing process requires different factors to take into consideration, and we want high flexibility within the technology that is going to be developed. And this project is going to be the foundation of our wider sustainability strategy within current, future, and legacy production facilities across the company. Can we go to the next slide, please? Yeah, this is a continuation of our key expectations and the technologies interested in adopting. We are interested in artificial intelligence, in large language models as the local instances, and we are looking forward for low-cost environmental sensing, which are going to be cyber secure, because as I mentioned, we will be using prototype IoT sensors to get environmental data, but we will be open to try out and trial new sensors on different connection types within Factory of the Future, but this will be dependent on the cybersecurity aspect. And we want to have a connected shop floor, which will result in an intelligent factory that we are all aiming from day 1. And we want to have the capability to visualize the environmental monitoring and integrate the findings into our human factors dashboards, which we will use in our factory. And as expected sustainability improvement, we are looking to reduce our energy consumption while producing high quality products, and we want to improve our production efficiency, to improve utilization, and to reduce the waste, and to improve our resource and energy efficiency. Can we go to next slide, please? So yes, this was our challenge statement, and thanks for listening. And as I said, I was Jen Capello and James was talking earlier, and here is our contact details. So please do not hesitate to contact us if you have any questions, or just put your questions where we will be more than happy to answer. Thank you.
Thank you very much, Cenk and James, for this detailed introduction to the challenges. We now will be hearing from HS2, who will be presenting the data-driven. Sorry. Can you see my screen? Yeah. I'll now be presenting. Would like to invite HS2, who will be presenting the data-driven decisions for the circular economy challenge. I'd like to welcome Zoe and Sarah.
Thanks, Yanni. Hello, everyone. I'm Zoe Edmonds. I'm a Senior Innovation Manager at HS2. Thank you so much for joining us and coming along today to hear about our Innovation Challenge. HS2 Limited, as hopefully you all know, is the company responsible for building the new high-speed rail line within the UK. Unfortunately, what a lot of people know about us now is that we are shorter than we used to be. However, what I believe that masks is actually just how big HS2 is. So we are still constructing 140 miles of brand new high-speed railway line. We are still building 4 stations, 2 depots, 32 miles of tunnels, 130 bridges, and fundamentally already have committed over £11 billion worth of contracts. The biggest construction companies in the world are helping us in this endeavour. We have major joint venture partners, including Balfour Beatty Vinci, FEH Kia, Skanska Kosken Strabag, Sir Robert McAlpine, Volkers, you name it. The big construction companies are helping us construct this enormous high-speed railway project. Now, because of that, and as part of that, we have a responsibility as HS2, as a government-funded body, to leave behind a construction industry and a rail industry that is more innovative, it's more sustainable, it's safer, it's better value for money, and it ultimately offers a better customer experience than you can currently achieve. That's our whole aim in the innovation team. We have a portfolio of over 100 projects already live so far. All of our joint venture construction companies are obliged contractually to work with us in this innovative way. So my colleague Sarah is going to tell you about a particular challenge we have and that we're starting to face now, because to construct this enormous railway means that we currently have over 350 live sites spread from London to the West Midlands to enable this construction to happen. And she will tell you all about how we would like your help in understanding how best to subsequently deconstruct those sites. Thank you.
Thanks, Zoe. Next slide, please, Yanni. So I'm Sarah Richards. I'm the Senior Logistics Manager for the HS2 project. And just a little bit of background on logistics at HS2. We look at enabling the project to be able to be built. So within our team, we look after the earthworks and the mass haul, so the movement of materials to and from the sites. We look at the traffic and the transport management, so how we get materials to site, how we don't cause complete chaos on the UK's road networks doing so, and also because we work in some quite rural environments and some quite urban environments, we have quite a lot of challenges. So we look at the logistical challenges in building something so big. And we also look at the construction logistics plans and assure how our contractors actually establish themselves to build the railway through all those hundreds of sites that Zoe just mentioned. And so that's kind of the logistics team we make sure we can facilitate actually building HS2, but not just building HS2, also we've got to look at facilitating demobilizing HS2, unbuilding HS2 at the end of the project. And this is where this challenge comes in. Next slide, please. So Zoe's already said, over 350 active sites across from the West Midlands to London. So when we say active sites, so we have the trace where you build the railway, but to support that build, there are areas for storage, there are areas for car parking, there are areas where we've built concrete factories, there are areas where we've had to put big concrete mats down so we can stand large cranes on them and piling mats and build other facilities. We've built some of our bridges offline and then pushed them into place. So the quantity of temporary works we've created is absolutely phenomenal. We have massive sustainability targets, and one of them, which I'll mention more than once today, no doubt, is to divert 95% of construction and demolition material away from landfill. So to put it back into that circular economy. So this means everything we've put in to creating these temporary works and building this railway, we have somehow got to get back out again. Next slide, please. So the challenge is to improve the deconstruction process, which is a significant challenge, and it requires data, lots of information from lots of contractors. Sorry, could you just go back on, Yanni? That's it, thank you. We've got, so all of these 350 odd sites are all being run by a number of different contractors across the trace. So contractors currently collect data about different temporary assets in different formats. And I will say it's not as consistent for the temporary assets as it is for how they're putting together the assets that will remain in place to actually build the railway itself. So it's stored in various locations, and it's hindering our ability to visualize what's out there and to be able to make data-informed decisions. So we need to streamline the data collection, enable to analyze and put some option developments in there. There's multiple different ways in which we can deal with this material that we've got in the ground now, and also, as doing that, meeting that 90% diversion from landfill targets. So next slide, please. So this is just to visualize it. So on the now picture, you have kind of what HS2 build site is looking like now. This is just one site of those 354. And the other picture, the next slide, is how it will look when we've finished. So all of those temporary works, all of those things that you can see that sit around the railway, has got to go back to, in a lot of cases, being green land, being pastoral land, go back to farmers, agricultural or other landscaped areas. So there's a lot to do to take the temporary works away that we've put in place to build the railway. Next slide, please. So factors that are involved in our project, so factors that we need to look at, the quantity of, we're calling them temporary assets, of assets on site, and what they're made up of, what their component materials are, because that then focuses on what we do with them. How we collate the design, the specification, and the survey data from those into a single platform. Looking at the carbon costs for material deconstruction and transportation of that material wherever it's going to go next. Equipment permits required to perform deconstruction process. So we know that we have some, we need some certain permissions in order to do certain things with certain materials on site. So it's a factor within the project. When is the asset available from deconstruction, and any deadlines for reuse? So we have an opportunity. We're currently in the civils phase of this construction project, so building the railway itself. We'll move into the rail systems phase over the next few years, and they may be able to consume some of the material that we have that we no longer need within that rail systems piece, but we need to know when each piece of the civils is going to be finished and how those programs fit together, and certainly how those programs might fit together with people external to HS2 that may want to have the material from us to reuse at the end of the day. We're looking at the geographic locations of assets and their potential processing and reuse sites, the time it takes to do the process, the value of the component materials we get from that deconstruction process. And of course, the big one is the options for processing into reusable materials. What can we do? What materials could we get back? How would we need to process them or deconstruct them to get them back? So they're kind of our thought processes around what this project entails right now, and how maybe technology could help us to assimilate all of that. Next slide, please. So what's there? So collate and analyse the available data on the site's current materials and fixed temporary assets within a reasonable time frame. And we're looking at maybe doing this in a pilot area or pilot areas. We're not talking about the entire 354 sites across HS2 before anyone gets too worried. But we would like to use that evidence to then quantify and see how this would work in sort of a bigger production environment and how it could benefit the whole of the project. So we may look to make recommendations based on the analysis of information based on carbon costs or different disposal options, different processing options, and the different reuses and those. So therefore the value of the materials once we've deconstructed them, and what they could be, what the best way to reuse those are, and the best locations in which to reuse them. And I think that is a roundabout summary of our project. Thank you.
Thank you very much, Sarah and Zoe. Last but not least, I would like to welcome Craig Concrete, who will be introducing their two challenges for the program. So welcome, Ramon and Neil.
Hello, everybody. As a part of the Good Friday Agreement, I believe we've got two challenges here, so we're a little bit unique in this project. So thank you very much for that. When I was listening to the other two presentations, I'm seeing and hearing quite a number of common themes and the same sort of challenges that we're facing, albeit maybe on a slightly different scale. And I'll be really interested in following up on the other two projects, because I genuinely believe they will have some use for our business. So I suppose onto our business, if we just go to the next slide, please. We are Crea Concrete. Everything that is used in life is made of concrete. Hospitals, housing, roads, HS2 in some parts as well. So within that, we have several manufacturing facilities: Edinburgh, Hobbingham, Tunbridge and Ardbow. We have found a niche in the market where we're manufacturing large structural products. And part of our challenge is making sure that we deliver those products on time in the certain sequence we require to our customers. Our customers would include most of the people mentioned by Zoe in HS2. So it will be Balfour Beatty, it'll be Boyds, Vinci, and so on. And our business is everywhere across the British Isles. So we've got projects down in Poole and Aberdeen as part of our active sites today, and we've got 73 active sites. Broadly speaking, we have 105 people employed or subcontract to ourselves at the minute, and we do about 150 million turnover, give or take. I suppose, next slide, please. What I want to talk to you about is the structures, and you can see in the photograph one of the buildings we have built recently. So effectively everything you see in the photograph on your left is a superstructure that we have built. That particular one is in Glasgow, and we effectively take it from the ground floor to completion. At the current stage, we have started the tallest building in Wales. It's 32 stories tall, and we design, engineer, manufacture and construct it from start to beginning to the end, just the superstructure, mainly out of concrete. Next slide, please. Can I have next slide, please? Thank you. Can we go to the next slide, please? So what we're trying to demonstrate in the video is some of the same things we've been talking about in the other presentations. So we've got a complicated product that is moved and manufactured in stages throughout an organically grown business. We want to find a solution that will track our prefabricated product from the second we actually do any of our design to the point at which we load it onto the truck to present to our customers. So there's two strands to that. The first strand is the asset tracking element, and again, we said that's a theme we've seen elsewhere. And the second strand is, what is its digital twin? What does that mean in terms of design evolution, process, and time frame? Both of those things are really important to us, as we'll try and describe as we go through. Next slide, please. This slide is primarily just to give you an idea on what a typical panel would be. So size and scale. We'll manufacture somewhere between 4,000 and 5,000 panels of a similar size and dimension per year, and the view is to grow that to 10,000 panels per year. This panel in particular is relatively straightforward. It's a sandwich panel without too much detail behind it, but we can get quite complicated in the shapes and sizes of the product that we make. Next slide, please. There will be a pop quiz afterwards. I want you to memorize all the process documents. But really what we're trying to give a view on is not only is there a difficulty in terms of understanding what our process is, physically where it moves around the yard, but we want to be able to try and track physically where that product is, what stage it's gone through, and then relate that back to our contract terms. Again, next slide, please. So effectively, we're looking at our sandwich panels here, and here are all of the sort of stages that we go through on a simplified version. We also have a route plan that reflects the physical movement in our next slide, please. And next slide, sorry. So this one here gives you an idea on what our physical movements are within the factories and all the general locations of the product as it comes together. We do have quite a number of repeats. So for example, it may move through stage 7. You can see it on the screen twice, 3 times and 4 times, based on acid wash, the exact finish we require. Within our facility here, we have a few challenges. Number 1, where is the product at? Where is the scheduling at? And how does that all relate back to the time at which we're supposed to present that to our client? That's one of the things we're hoping will be solved in the challenge. We also have, would you believe it or not, on an 80-acre site, issues with finding product, physically where that is, where does that reside in the yard, and there are challenges associated with that that I'll go into later on. Just to give you a little bit of an idea of how those challenges manifest themselves, can we go to the next slide, please? And this is effectively the makeup of a typical sandwich panel, which can be up to 16 tons in weight. And you can see the rebar in the pink shadowing within that, the yellow insulation, the concrete faces, and there's often lots and lots of various attachments to it. Go to the next slide, please. And the next slide, please. This is our biggest problem. Our problem effectively is that we have no mobile network whatsoever. We're on the edge of the Loch Ness, and we have no 3G, 4G, and when we step outside the office, there's no easy way of communication. We have no Wi-Fi out through the 60, 70 acres of the yard. And when we do have items attached to the panels, they are in a hostile environment. The previous slide that showed the rebar shows that there's difficulties in terms of communicating signal from a product through the rebar. Concrete itself is a very hostile environment. It's alkaline, there's exothermic reactions, and therefore the durability of any product we've used so far is very, very questionable. So what we really need is something that's allowing us to track this physical product as it moves through the yard and have effectively geofencing between each individual stage of manufacture. Next slide, please. I'll pass over to Ramon.
Okay. Thanks, everybody. I hope that you're still awake after a full session. I'm the challenge, the owner for the Challenge B within CREA. And this challenge is, the background of it is actually a problem that I have. I'm currently responsible for the planning with the operations in the main yard here in Tunbridge, Northern Ireland. And the pain that we have is we have such a variety of different products that is manufactured in so many different ways, depending on the spec for the project, that it's very difficult to standardize the processes by which we manufacture each one of the units. The previous slides from earlier have seen different product. They are two different sandwich panels for two different projects. They look absolutely completely different. The way they are manufactured is absolutely different between them. So the challenge is, as you can read there, we need to improve the planning, and in order to improve the planning and the consequence of the contract side, all the contractual obligations that we have with the customer, make us more efficient, make us use resources and labor better, etc., we need to start capturing and analyzing data of our own manufacturing processes. If you can take the next slide, please, Johnny. We can basically, at one stage of the entire process that Neil showed, there is one specific location that we will be doing the majority of the tasks within the manufacturing process of a sandwich panel. Typically, most of them are manual. They're carried out by operatives, and they are almost the same, but they tend to change project to project. Similar within the same project for different units, not the units are different in between them, so that it's the crux of the manufacturing business, where we have a very high volume because we're a big company, and a very high variability because every single project is different. So at present, we don't want to direct into which solution we want to adopt. We don't want to say, and I'll say it anyway, we don't want to say tracking the operatives, or they input the information on the tasks in some kind of gadget, either virtually or not, AI through video recognition in cameras in the factory. We don't want to really direct to a solution. We're open to all of them whilst they actually fit the constraints that we have. Next slide, please. This is an example of the tasks taken for one panel. On the picture on the right, you basically see a tilting table that is basically tilted, and you can see a mold in place. The process currently involves a lot of different steps that happen at that location that we currently don't have the ability to track. So this is just an example of the task that we want to track. And just next slide, please, Jenny. Basically, the must-have of the challenge is we need to collect the duration of each one of the tasks, and with the challenge that these tasks will not be the same for every single unit, for every single project. So the system needs to be able to adapt to these requirements, that they might change, and it be able to feed us back information as to which is the best way of planning and producing the next unit, the next project. That's in a shell what we're looking for. Thank you. Next one. Thanks, Yanni.
Thank you very much, Ramon and Neil, for going through the details of the challenges you're participating in the program. Now we have some time for questions and answers, either to Digital Catapult team or the industry challenge owners, and I will invite all industry challenge owners to turn their cameras on. So just a few questions to kick off. The first question I'll kick off: what type of data might the cohort get access to? So probably that will be a good question for everyone. Let's pass over to Cenk and James, because you mentioned a little bit more details around that, and then if anyone wants to add to that question.
So the question is, what data will the team assigned to this get access to?
Yes, that's correct.
Okay, so like we mentioned, we'll be installing a series of sensors, Arduino-based sensors. They will include, amongst other things, air quality, airflow, atmospheric temperature, pressure, UV index. We'll have a weather station which will have rainfall, wind speed, that kind of thing. On top of that, as I mentioned, we also would like to sync to any environmental information you would get from the internet, like the weather forecast, which makes sense to sync up to the data feeds. The other thing that we mentioned about emulating data, and again, this comes to, there will be restrictions. We are very familiar with these programs, and we want to ensure that things happen at the right pace. The second we need to get what would be termed as company or customer marked data, stuff that moves into the realm of sort of government mark, that kind of thing, it becomes tricky. So we would likely be able to offer information about machining processes. We might be able to offer things like emulated machining paths and robotic tapes, that kind of thing, that would be similar but not identical to an actual process, if that makes sense. So emulated information that's representational of a typical process or a tolerance requirement is what we'd be able to offer. We wouldn't be able to offer stuff that's actual production part information for obvious reasons. It would slow the project down. So hopefully that answers the sort of information you get access to. We would intend you to have some time in our facility, because by being there you would see and you would meet the people that are doing the development of the processes. That's the whole point. And like we mentioned before, a lot of what we want to implement, we want it to be local for a lot of reasons, but also because when it's local, you can actually look very closely at what's developed like an MVP. And when we talk about things like green software, green AI approaches, which I'm hoping a lot of you will be asking, it's a lot easier to understand and articulate what an actual process, if you're developing an AI, for example, is consuming during training, during use, if it's on the coalface, if it's running on a box somewhere. And it also challenges you to make it very efficient because of that environment. So hopefully that's a good answer.
Thank you very much, James. And there is a question to Cenk in the chat. Have you considered optimizing when you run actual AI algorithms, optimizing based on optimum electricity usage, best location, time of day, energy source?
Yeah. These are all taken into consideration, and we are much looking forward to utilize this learning as well. And we are interested to understand how can we get the information, how we can make the comparison, and how we can align this to our production needs as well. And that's why we want to utilize and collect as much as data sets as we can for this project. So we have a lot of historical data sets so that we can compare and build up on that by optimizing our processes to the national grid need, or for example the demand, and to see if we can, for example, start the production a bit earlier or a bit later, aligning with what's available on the grid. So yeah, we are all considering, and it will be part of this project as well, and we will put that going forward.
Perfect. Thank you very much. There is another question for CREA Concrete this time. Would quality control also factor into the assessment and tracking of CREA's products?
The quality control, we're going to be reliant on another system. We don't see it as part of the scope of this project, but it would be phenomenally useful if we're able to link the physical tracking with our quality data. So we've got a quite extensive program ongoing in parallel with QA and quality control systems. Does that answer the question?
Perfect, thank you. There is another question for HS2 this time. Is the challenge specifically focused on analyzing the material data, quantity, etc., to make it available for decision makers, or it is also about calculating carbon footprint, recommending where, how to recycle or reuse the materials?
Both. So we've got both of those work streams within the project at the moment. So and we think the decision making is also linked to the carbon footprint. So it's not just about cost, it is about carbon. So we have both of those elements within the project.
Perfect, thank you. There is another question for BAE. One is, can you please share what has led you to believe that the challenges in the environment in the future factory, the factory of the future is having a significant impact on productivity, and what is your dream outcome of this engagement?
Right. Okay. I'll answer the first one first and the second one second. That's probably sensible. So let me explain. The factory of the future is, giving context, it's in the oldest hangar we own. The roof is 3 millimeters thick. Okay, that gives you context. The floor actually moves. If you laser inspect the floor day in, day out, it moves because we're near an estuary. We also have the oldest building management system on the entire Northwest division of the company. All those combined, it's not where you would typically want to put a future factory. However, that is where we put it because that is where the facility could be when we built this as a test facility. It's now moving towards production. So by doing this, we started with the worst, and essentially we started with an intent to try and achieve the best tolerances for future manufacturing with the worst possible environment. The reason we have done this is quite simply because we want to avoid creating a controlled environment requirement. It's all too easy to say, let's build a sealed box with full temperature and humidity control that requires power, energy, and constant consideration. We decided it was much better to try and push processes to the absolute limit, which we think we have. Now understand where those limits just are too much, i.e. during a heat wave, during a cold snap, during certain times of day and night cycle, during particularly heavy high humidity and rainfall. Those are the sorts of things that cause us the challenges where we do struggle to meet certain tolerances, especially during calibration. And that is where we want to start understanding how we can improve the environment a little further. But at the same time, we want to do this in the most intelligent way possible to infer that, again, while we're doing it, we're not just burning energy to do it. The whole point is we're trying to avoid that from the beginning. And what was the second question, sorry? Oh, you mute, sorry.
Yeah. The second question is, what is your dream outcome from this engagement?
Again, as Cenk mentioned, it's a bit of an open project deliberately. We are, let's say what our dream engagement is more. We, in the future factory, and I'll explain, this is exactly how we left it with our last Digital Catapult engagement, where it was all about AI for visual inspection. We had a explicit set of problems, which we're defining here, like we did in the last program, where we as a company, because of the kind of manufacturing we do, have a specific problem set. In the last project, we set the challenge that we have this problem. We would like you to tell us what the best kind of solution might be. So coming back to my point, my ideal engagement is to have a SME that goes, right, I want to work this through with you and develop the use case and come up with some ideas that maybe we haven't thought of, maybe that with technology or interests or learning or knowledge that these companies that can apply for this have that we might not, that can come on board. Because again, if this relationship goes well, just like the last program, you'll end up being a partner of ours and moving this into into maturity and into ultimate deployment into several facilities. So there is no end game at the moment. There is a problem. We'd like to understand all the ways that that problem could be sort of improved.
Amazing, thank you very much. And I have a question to around the program, who keeps the IP? And I will ask Gavin to answer that question.
Thank you very much, Yanni. So the simple answer around IP and who gets to own it for anyone watching this is you do. This is not a program that aims to take any IP away from anybody. This is not a program that aims to take equity in any of the companies that we work with. So hopefully that kind of puts people's mind at ease. This program is essentially looking to try and find innovative companies in industry to work with the challenge owners that we have here to develop a solution to support some of the challenges that they have. Working alongside them, you will get kind of support from them and access to certain kind of data and what have you to help develop and build those things out. But at the end of the program, whatever you've developed is yours to continue developing if you want to take to market if you want to. Hopefully there will be some conversations opening up around continuing to work with the challenge owners beyond the scope of this program. Things all going well, hopefully that would still be the case. But you would, of course, be able to take anything that you've made through this program out to the wider market, to any other companies that are having similar problems. So yeah, bottom line, IP stays entirely with you. So hopefully no worries there at all.
Thank you very much, Gavin. In terms of the next question, which you have on the chat, do you use any public cloud solutions such as Azure or AWS? I guess this is across all challenge owners. Questions for everyone.
Who do you want to, I mean, BAE, as I mentioned, our solution is we want this to be a local one. Again, the reason we're saying don't use a cloud for this is it shortcuts any security questionnaires, any export problems. It speeds the process up. We do not want to be waiting 3 months for someone in security here to agree that you can use your cloud solution to host our data. That's off the table because it will just slow it down. We want results, so we're going to go local for all this. But in answer to the cloud thing, BAE is an Azure partner. We're a strong Microsoft partner. We are developing big cloud systems at the moment. We're already using secure data in clouds. We do have links into AWS as well. We are very familiar with it. The conversation can include this, i.e. the long-term goals for a project. Our IoT solution in the Future Factory does include a cloud plan, but please don't consider it as any way of manipulating data in our project.
Thank you very much, James. Does anyone want to add to that question?
We would have a very similar approach. Certainly some of our contracts are with the custodial providers. There's quite significant barriers there in terms of security of data, design, and so forth. So we would echo exactly what James just said.
Thank you, Neil.
And just to add, Yanni, from an HS2 perspective, as everyone can probably guess, it's a relatively similar answer. For this kind of data and for this kind of proof of concept level project, we would be very open to a cloud solution, actually, because I think it would be very appropriate. It would make a lot of sense. When it gets to, we have to be very aware of data security levels. So when it gets to more commercially sensitive data, and any more kind of data analysis of HS2 data specifically, we may need to be more careful. But in terms of data that we can simply model, data that's available simply by looking at and measuring sites, we're imagining kind of drone site surveys and things could assist with measuring these sites and approximating materials that they're made up of, etc. All of that, it would seem to make sense, would be cloud.
Thank you very much, Zoe, and everyone. Moving to the next question, which is for BAE Systems again. Can you please confirm what sensors you have already in place, temperature, humidity, etc.?
So I think I gave a reasonable response. I'll just reiterate. So Arduino-based sensors Again, just to be clear on everyone on the security front, it's not a bad idea to raise this now. We have to be mindful of the origin of the hardware. I'll just leave it at that. You probably guess what we mean by origin, i.e. global space, where it's sourced from. We have these Arduinos being installed. There will be, I think, 10 of them. And there's a weather station. Again, that is a US-based company that provides this weather station. So at a bare minimum, it would be 10 environmental sensors and a weather station. I've mentioned some of the feeds we were getting on these before: temperature, humidity, UV index, etc. And on top of that, we are getting power taps, power clamp systems, and also injection points into cooling and heating ducts, so flow sensors and heat sensors for them as well, which will be of a similar origin, probably an Arduino with a Wi-Fi controller. That'll be running through a Wi-Fi network, which will be a secured Wi-Fi network to a small form factor PC. We will be hoping that whoever comes on board will either be able to run whatever they want to on this PC, or at least do some offline testing in their own systems with the data we give them, and then when we agree or arrange it, come in and sit with us and try and deploy what they've got on our systems in the factory. The long-term goal, of course, is to move away from this and to link all this into our wider factory network. The whole point of this is we want the environmental piece to link to the wider factory management piece, which is its own separate project, which we'll share with anyone who's successful. That's a whole several-hour conversation about the work we're doing there. But suffice to say, although manufacturing output is critical, as you know it is, the net zero drivers are critical too. We intend to link all of this work one day into a fully intelligent factory that takes account of where the power's coming from, what the environment's doing, what the process needs, what the customer needs, and make the right decision based on all those factors. But that is a hell of a long-term goal for us.
Thank you very much, James. And I have a couple of questions for Crea. Concrete challenge A. You hinted that you had tried different tracking things in the past and they had failed. Could you please say what didn't work?
We in association with a local university, we developed our own sensors that were manufactured locally. They were to try and utilize Wi-Fi, which is phenomenally limited on the site, and also then to give us idea on what our curing was, what heat was, what was the level of moisture left in the concrete, and track. We found the sensors themselves were very hit and miss in terms of the ability to communicate past that hostile environment. So on very, very narrow panels, they would work quite frequently. Once we started introducing wider panels with more rebar and more concrete, there wasn't enough broadband width for them to communicate effectively. However, we did find that that technology would be very useful in another setting, and we have gone on to use it in another factory in a sort of simplified version of what James is discussing. So it has been phenomenally useful for us to do that. And we've got an ongoing research project with the same guys in Queens to utilize that in a fixed location. And to be fair, it is working exceptionally well. Our challenges here are more that if I go back to those original sensors, they were really useful when you're proximate to an operational sensor. So if you're close to it, we can determine it. But on an aviator site, it's quite difficult for us, if we're tracking a specific panel, to know exactly where it is. So therefore, there has to be a broadcast signal of link back to a GPS location in some manner. And that's where our previous devices failed. Failed in this environment, but were phenomenally useful elsewhere.
Thank you very much, Neil. And I have a couple of questions to Ramon. The tasks that need to be tracked, can multiple tasks take place within a simple location building? Or does each task have its own dedicated location?
To be very brief, for the challenge B, yes, there will be different multiple tasks in the same single locations. And then no to the second one. We will start just with one single location. That would all the tasks happen basically one single shed, and all the tasks will happen within that shed. But if it works, we'll try to export and integrate to other locations. Happy? Yeah.
Perfect. And the next one is there a quality control process within the panel forming process?
Yes, there are a couple of part of the quality control system that we have. There will be one step within the panel forming process. They would require within that location, there is one hold-on point that is quality. Yes.
Perfect. And then there's another question which comes for the first challenge. You have asked that a provider brings a network as part of the solutions. What are your expectations here? A full network for the full size, or happy to put a small network in place with a couple of access points to provide to prove initial pilot? Or are you looking a software provider to partner with a network provider to do a full-scale rollout of a larger network?
I suppose ultimately we would have a strong desire that we've got coverage for effectively every square inch of the facility here, and not just this facility. Haveringham has similar challenges. Edinburgh has a similar challenge as well, but probably less so. But we are flexible enough to say, right, if we've got something that works in several locations and we can scale it over a period of time, then we're perfectly happy to do that. We also recognize that there's a possibility that given the product restrictions, I'll call it, that we may have to go globally Wi-Fi for the entire site, which is certainly a significant step up in terms of CapEx and time frame. But we are open-minded about that if that ends up becoming the proper long-term solution. But at this stage, it's relatively limited within the scope of this exercise. We want to see that it works. We want to see that it works in several locations, as Ramon has just said, and then we'll take an open mind approach after that point.
Another question to Ramon. What systems are you using for planning at the moment, and what kind of data do we get access to?
Systems at the moment, we have a bespoke software that we use is web-based, and it helps us planning within the main operations, rough planning, and the specific scheduling for each week. It's a bespoke piece of software that is Windows-based. There are other independent pieces that we use. Nothing particular is fancy. Project Excel, etc. Just general software that we use for planning. We tend to move as much as we can to the cloud and collaborate, particularly within the Office package. But other than that bespoke piece of software, we call it Mint, by the way, that has been bespoke developed for us, and it helps us keep tracking of all the production. It links to accounts. But that was for the planning software that we have at the moment and system. And kind of data that we get access to, that's to be discussed. But if it's not into any of those sensitive customers and projects, we are a pretty open company in the sense that just ask and you will be probably given access to. Okay. Yeah.
Thank you. And a question now for HS2 team. Are there existing systems that capture data of materials used? If yes, do you require integration across all data nodes?
Yes, there are, but they will require integration. There are different systems, there's different tech, there's different information. So yes, that is part of it, is trying to assimilate that together. Zoe, anything to add on that?
No, I fear we may be terrifying people with the data integration challenge. I promise this is just a pilot, so we're not expecting you to do every one of those companies that I listed at the beginning and that kind of thing. But we do have AIM software. We do have 3 different drone suppliers who are doing site scans, and we do have an enormous number of software programs that simply export to Excel. So bear in mind, this is the construction industry, that there is a huge amount of variability, but there is quite often an Excel backbone in there somewhere. So yes, data integration will be a big part of it. It'll be really interesting.
We're still very fond of a CSV file. Thank you.
Okay, thank you very much. So there's one question for you as well. Is the expectations that contractors and other site staff are providing data in some format regarding temporary assets?
Yes, because we won't be able to do this project without liaising with our joint ventures or our contractors to get the data. It's not data necessarily that I would hold as a HS2 person. It sits within their companies, and we'll be working together.
Thank you very much. And one last question, which there are lots of questions in the Q&A, but just one last question to all challenge owners before we wrap up. Will NDAs be required as part of the collaboration with the ICOs?
So answering this question from BAE side, so once we have the initial down selection at the end of the judging process, before the interviews begin, we will need to have some required information from each of the SME and startup, and we will need to have NDAs in place to be able to do the interview. But this will be handled from our side, and this shouldn't take too much of our time.
Thank you very much. Anybody else?
From an HS2 perspective, we try to avoid them. We're a publicly funded company. We're FOIable for most of the work that we do. So we try to be as open and transparent as we can. Equally, we recognise we don't want anyone's IP to feel threatened, and we don't want any commercially sensitive data to be a concern for any of our contracting partners. So all I can really say at this stage, until we understand a little bit more about the kind of solution you're offering, is we would like not to. We would like to be just open and transparent about it. But if people have concerns, then we're happy to engage.
From Craig's perspective, we will be asking for an NDA, but I don't think it'll be an extraordinary high hurdle. It'll be relatively straightforward.
Amazing. Thank you very much for all your answers and your engagement. Thank you for joining us today and being so engaged and putting so many questions in the chat box. Now we'll just do a quick wrap up. I'm going to share my screen again. With a little bit of information here. Just a quick to talk you through to the next steps. If you didn't get an opportunity to ask your questions, or there is something else come up as you're filling out the application form, please do get in touch with us via Made Smarter Sustainability email address, which we shared in the chat box. Then we'll follow up in the email after that. And also please note that any inquiries that will be sent to this email will be monitored during office hours from 9 to 5. As you can see here, we've got a QR code that leads to the program briefing page and contains all of the information on the challenge briefs and the program itself. And also has a link to the frequently asked questions page. So please check it out. That's all from us. Thank you all for joining. Thank you to our industry challenge owners for presenting, and we look forward to your applications. We'll follow up with an email sharing the link to the recording as well. Thank you all for joining us today, and good luck with your applications.